most diverse ecosystems on Earth. They're made by coral polyps, tiny animals that build huge reef structures. You'll find large reef-building colonies, soft-weaving fans, and thousands of species living there. Does anyone know anything else about coral reefs?
Coral reefs are usually found in warm, shallow tropical seas, but some live in cold, deep waters. They also support 25% of marine life, and scientists are still discovering new creatures.
Correct, but they also face huge threats such as climate change, declining water quality, overfishing, pollution, unsustainable coastal development, bleaching, and much more. This is all a result from ocean acidification.
Okay, this is serious. What else does ocean acidification do to these beautiful coral reefs?
I know. It also reduces carbon and ions. Those are like the building blocks for coral and shellfish skeletons. With fewer of them, it's harder for marine animals to grow shells or reefs. Even businesses like coastal fishing and tourism especially are going to get hit hard by this.
So it's not just about fish, it's about people too?
Exactly. It affects the whole food web and even how fish behave. Ocean chemistry changes the ocean's balance, and that puts everyone at risk. Let's look at some corals now.
Whoa, coral reefs used to be so colorful. What happened to them?
Sadly, they're in big trouble. Corals all over the world are now becoming endangered.
Endangered? Why?
Well, it's mostly because of climate change. Two big problems: coral bleaching and ocean acidification.
Coral bleaching? Are they getting their hair done?
Not exactly. Coral bleaching happens when ocean temperatures rise. Corals have tiny algae living in them called zooxanthellae that give corals food and their vibrant colors. Now say it.
Zooxanthellae?
When the water gets too hot, the coral gets stressed and kicks the algae out. Without this algae, the coral turns white, bleached, and it stays that way, and if it stays that way for too long, it can die. That is what we call coral bleaching.
Oh no! Can it ever come back?
Great question. Only if the ocean cools down and these stressors go away. Then the coral can reabsorb their algae and recover. But with rising temperatures, bleaching is happening more and more frequently.
That's terrible. What about ocean acidification?
Another great question. Remember the experiment where we blew into water with a straw and it turned more acidic?
Yep, the more we blew, the lower the pH got.
Exactly. That's what happens when carbon dioxide from the atmosphere dissolves into the ocean. It forms carbonic acid, which then lowers the pH of the seawater. Now this is an equation to represent that. CO2G plus H2OI equals H2CO3.
So the ocean is becoming more acidic from all the CO2?
Yup, the ocean absorbs about 30% of the CO2 we release. The more CO2 it absorbs, the more acidic it becomes. This is bad for corals and even baby shellfish. The acid can actually dissolve their shells, and even shells on the beach that we like to pick up.
And that's bad for corals as well?
Super bad. Acidic water makes it harder for corals to build their skeletons. It's like trying to build a house with soggy bricks.
Yikes, but what's causing all the CO2?
Humans. Here are 4 big causes. First, the burning of fossil fuels, like coal, oil, and gas for energy. That releases tons of carbon dioxide into the air. 2, deforestation. This is when people cut down forests, and this equals fewer trees, and trees actually absorb CO2 if you didn't know. 3, driving gas-powered cars. Gas-powered cars burn fuel and emit greenhouse gases. 4, factories and industrial processes. These both release tons of CO2 and other heat-trapping gases, which in turn makes the Earth warmer. Also, analyzing ocean chemistry chemistry can help us understand what's causing this intense acidification. Changes in ocean chemistry affects behavior of organisms like fish, which in turn affect the entire food web of the ocean. Now let's dive into the chemistry.
Dive into chemistry.
Carbon dioxide dissolves in the ocean, which then reacts with water, H2O, to form carbonic acid, H2CO3. Following this equation, CO2 plus H2O equals both ways, H2CO3. Also, did you know that 30% of the Earth's CO2 in the atmosphere is absorbed by the ocean? This is another reason why oceans have become so acidic in recent years.
So more CO2 equals warmer oceans and more acidic oceans?
Bingo! Warmer oceans equals more coral bleaching. Acidic oceans equals weak coral skeletons. It's a double threat.
What? That's wild. How can we visually show this?
Check out this graph.
Yeah, there you go.
This graph here shows how human activities increase the amount of carbon dioxide in the atmosphere as time goes on, and how the energy imbalance continues to grow. The concentration of carbon dioxide in seawater increases, in turn making the pH of the seawater lower and the acidity in the ocean greater. As you can see on this graph, from the year 1960 to 2010, the atmospheric CO2 increased by about 315 to 390 in 50 years. This is predicted to continue increasing as time goes on, and in turn making the pH of the sea water lower.
But what about the blue line? It's going down.
That's the ocean's pH, or acidity. It's going down, which means the ocean is getting much more acidic. And the darker blue line is increasing because it represents the concentration of CO2 in the seawater. They go hand in hand.
So how can we analyze the Earth's energy coming in and going out of the Earth?
Good question. We can notice Earth's energy budget.
Budget like money?
No. Earth's energy budget refers to the tracking of how much energy is flowing into and out of the Earth's climate. Human activities increase the amount of carbon dioxide in the atmosphere. This energy imbalance then continues to grow.
Oh, so we can use Earth's energy budget to predict future events of climate change.
Exactly. We can also model Earth's intake of CO2 using feedback loops.
Okay, give me a second. Carbon dioxide traps heat in the atmosphere and Earth's energy budget becomes unstable, disrupting the carbon cycle. Then, the ocean absorbs CO2, lowering pH and making the ocean acidic. This then leads to ocean acidification and coral bleaching, in turn hurting ecosystems. Then, this caused ocean acidification leads to decrease in release of DMS, a sulfur compound that helps form cloud condensation nuclei. Finally, less clouds form and higher emissions of CO2 are released, making it a positive feedback loop because it reinforces global warming. Is that right?
Spot on. Good noticing that it's a positive feedback loop. Now it's time for you to continue working on your essay.
Wait! I have one more question. How can we prevent CO2 emissions and this from happening to our reefs? I'm supposed to go to Australia this summer and swim by the Great Barrier Reef.
I'm glad you asked. First, let's discuss adaptation and mitigation. Adaptation is helping ecosystems to cope with changing conditions. Mitigation is preventing these issues to begin with. First, what can we do involving adaptation? First, scientists can develop more acidification-resistant marine species and manage local water quality management, like preventing chemical runoff to oceans. To help with acidification, scientists could add alkaline substances to seawater to buffer acidity.
What about growing coral in nurseries and replanting them on degraded reefs?
Good! That's a great way to use adaptation to stop ocean acidification. Now let's discuss mitigation. Developers can regulate coastal development and implement zoning laws to prevent overdevelopment near reefs. Developers could also create buffer zones to limit runoff from sediment and pollution.
But what can I do personally?
You could also personally reduce harmful sunscreens and use reef-safe sunscreens.
We can also help restore damaged reefs by using coral gardening and grow coral fragments in nurseries and transplanting them. Thanks for all the help. Now I feel educated on CO2 emissions and how they affect our coral reefs, but we have to do something.
Yes, lower emissions, protect forests, and use clean energy. It's all up to us.
All right, time to be coral heroes.
For the reefs.